want to start with a small problem. So let's assume your graphicer or graphic department gives you assets like this, and you as a Qt Quick developer should somehow make this into a real application. But it's not just that you have the images, but these images should, for example, be scalable. So you have the single elements, like in the clock you have the single ticks and the clock handles, and your task is to implement this in QML. Or if you have the tachometer, there you also have these ticks and you have the single numbers, and you should position them somehow in a circle. So you see there's a reoccurring problem. We have some elements, UI elements, and we want to position them inside a circle. So what would be the naive way to do it with Qt Quick? Well, we have more or less always the same elements, so we can use a repeater to make it a bit declarative. And for example, if we want to implement such a clock, then the clock ticks would simply be rectangles. And we have to position the rectangle somewhere. That means if we want to position them along a circle, we have to do some math, like calculating what is the position inside our Cartesian coordinate system depending on the current angle. And here in this example, we have a model with the number 20, so we have 20 elements. So we instantiate 20 rectangles, and depending on the current model index that we get from our model, we calculate the current angle, and then we use some math that involves the center point, the radius, and the math functions from JavaScript to calculate the x and y coordinate. And of course, you don't want to have the rectangles all upside, but you want to rotate them depending on the current position. So you would need some additional code to calculate the actual rotation angle depending on the current position. So you can do this for one clock, but maybe you have other elements. So you would basically copy and paste the code. And we know that JavaScript is fast, but we can do it faster with C++. So maybe there's a better solution instead of hand coding this in JavaScript over and over again. So let's go one step back. Normally, you shouldn't do calculations directly inside QML. Instead, you want to use a declarative approach. You want to encapsulate all the logic in a module that you can simply reuse. And this is done in Qt Quick already for positioning other elements in rows or in columns, in grids. These are the so-called positioners. And we have them. They are shipped with Qt Quick. We have it for row, column, grid, and flow, but unfortunately not for a circle, so that we can use polar coordinates to align elements along a circle. Okay, so if it doesn't exist, I thought, well, I could try to implement it myself. And when you look at the source code of Qt, you will see that all the existing positioners, the grid, column, flow, and row, all have a common base class that is called QQuick base positioner. It's a private class, so you cannot use it directly, but, well, we have the Qt source code, right, so we can nevertheless access private API, and I aim to upstream this feature, so it's not a bad thing to use private API. And this QQuick base positioner has virtual methods, two virtual methods that you have to override. This is do positioning and report conflicting anchors. The do positioning method is called whenever a new child element has been added to the positioner, or if it is removed. So inside the do positioning method, you have to do the calculation where all the child elements of this positioner should go inside the coordinate system. And the report conflicting anchors method is called where you can do some validation. Because if you put items inside positioners, they shouldn't use anchors at the same time. Well, it depends a bit. So if you put items in a row, for example, they still can have anchor at the top and bottom. They can use the top and bottom anchor line, but they are not allowed to use the left and right anchor line anymore. Though in this method, you can check what anchors the items have. Yeah, so if we want to implement our own polar positioner element, we have to override these two methods, and we also need some properties so that we can configure it. So we want to have a from angle and to angle so that you don't always have to align these items along the full circle, but can say, I want to start from here and then follow up until here. You have to define somehow the radius, and you also might want to say the direction. Okay, and I will just show you a bit of code, not for long. So basically I implemented a new class that inherits from QQuickPositioner. I added the properties and I re-implemented these virtual functions. The interesting part is the do positioning, where I simply take the angle and calculate from the start and end angle what is the difference between these two. And then I know how many steps I have. And then I do the calculation you have seen previously inside JavaScript. So here I also calculate the x and y position. And then I call the function position item, where I tell, okay, this item should go at that position. So you see the complete logic is more or less just one page of source code, though it's really easy and simple. And now when we register this element, we can use it inside QtQuick. So now it's an official part of QtQuick, so to say, and we can simply use our polar element. Here we want to implement a clock, so we use one polar element. We say it should start from angle 300 to angle 217. This is a bit strange because the angle starts normally, if you have a circle, it will start at the at the right-hand side. This is how the coordinates are calculated, and we want to go clockwise between these two angles. I define a radius, and then I have to add all these elements I want to display there. And of course, I use a declarative approach by using a repeater. And when we execute this, you see here I have all the rectangles that are drawn automatically. I used an attached property angle to center, which I simply assign or bind to the rotation property of my rectangle, and I do basically the same for the numbers down here. So I have two polar elements and two repeaters. And since these properties of the polar element are normal properties, I can also put behavior on them, so to animate them. Like here, I want to animate the radius of my polar element, and when I execute this, we get something like this. And I can, by simply putting animation on it, also animate or putting a behavior on it, I can animate properties like radius, but also I could animate the angles that the circle is turning around. Yeah, so that's how it's work. What is the future? What are my future plans for this? Basically, it might need some code review and some cleanup. Then, of course, writing all the documentation so that it is on par with the documentation for the other positioners. And then, at some point when it's ready, I will try to upstream it to the official QtQuick module. Okay, that's all for me. Thank you very much for listening.
Thank you, Tobias.